Good afternoon, everyone. Today we will discuss question number 8 of end semester examination. The first part is compare decision trees, random forest, and boosting, highlighting strengths and weakness of each. Decision trees concept a single tree built by recursively splitting data based on feature values. Strengths are easy to interpret and visualize, tree structure in human readable, it requires little data preprocessing, handles numerical and categorical data, and fast training and prediction for small trees. Weaknesses are high variance, easily overfits the training data, unstable, small data changes cause very different trees, and lower predictive accuracy compared to ensemble methods. Greedy splitting may fail to find global optimum. Second is random forest. Concept an ensemble of many decision trees built using bootstrap samples and random feature selection, that is bagging. Strengths are reduce overfitting, averaging many trees lowers variance, high accuracy and robust performance, works well with large high dimensional data and is less sensitive to noise and outliers, provides features important scores. Weaknesses are less interpretable than a single decision tree, slower than a single tree due to many models, may still struggle with high variance bias problems, and large forests consume more memory. Third is boosting. Sequentially builds models where each new week learner focuses on correcting errors of the previous ones. Strengths very high accuracy, often best performing machine learning models. Reduces bias effectively, unlike random forests that reduce variance. It works well on complex nonlinear patterns, highly customizable, learning rate depth and estimators, etc. Weaknesses are prone to overfitting if not tuned properly, slower training compared to decision trees and random forest, sensitive to noise or outliers, especially ADA boost. Many hyperparameters or complex tuning. Second part is explain the architecture and components of Hadoop, HDFS Yarn MapReduce, or describe Spark and its advantages over MapReduce. Hadoop is an open source framework designed for distributed storage and parallel processing for large datasets across clusters of commodity hardware. Its architecture mainly consists of HDFS, Yarn, and MapReduce. First is HDFS, that is Hadoop Distributed File System. Architecture, name node, master node managing the file system namespace. It stores metadata, file names, block locations, and permission. Data nodes, worker needs storing actual data blocks, sends heartbeats to name node. Key features are block based storage, default 128 MB blocks. Replication, default 3 copies of fault tolerance, high throughput for large datasets. Second is Yarn. Yarn stands for yet another resource negotiator. Architecture components, resource manager RM, global master allocates cluster resources, node manager NM, manages resources on each node, CPU or memory, application master AM manages the lifecycle of a specific application role, separates the resource management from job processing and improves scalability and cluster utilization. Third is MapReduce. Architecture map phase produces input splits in parallel, converts data into key value pairs, it shuffles and sorts, it redistributes and sorts intermediate output, it reduces phase, aggregates or summarizes map data, features designed for large scale batch processing, and fault tolerance is scalable. Describe Spark and its advantages over MapReduce. What is Apache Spark? Spark is an open source cluster computing framework designed for fast in memory data processing. It supports batch processing, real time stream processing, machine learning, graph processing, and SQL processing. Core components of Spark: Spark Core in memory computing engine and task scheduling, Spark SQL structured data processing using SQL or data frames, Spark streaming or structured streaming real time data processing, ML library distributed machine learning library, graphics, graph computations, and cluster managers Yarn, Mesos, or standalone mode. Advantages of Spark over MapReduce. First is in memory processing. Second, supports multiple workloads. Third, easy to program. Fourth, DAG, that is directed acyclic graph. Fifth, fault tolerance. And sixth, higher resource efficiency. Thank you so much for listening.